Hello all, this is M. Sandeep Kumar and I welcome you back to my YouTube channel Concepts of IIT Maths. So in our previous video we have seen some important models on sum of n terms of AP, and in this present video let us see as many problems as possible on nth term and sum of n terms of AP. So out of these problems, the first one is written on the board already. The first question, the sum of integers from 1 to 100 that are divisible by 2 or 5 is. The sum of integers between from 1 to 100 that are divisible by 2 or 5. So to solve this problem, let me use a basic concept on sets. I hope you remember this. You might know this, that number of terms in A union B, in two sets A union B is equal to n of A plus n of B minus n of A intersection B. Okay, so I'll use the same concept here, that sum of the numbers divisible by 2 or 5, union is nothing but R. Okay, the sum of the numbers divisible by 2 or 5 is equal to the sum of the numbers divisible by 2 plus sum of the numbers divisible by 5 minus sum of the numbers divisible by 2 and 5. What does it means? I'll take all the numbers divisible by 2. Next, I'll take all the numbers divisible by 5. But if you observe one thing, in the multiples of 2, I have multiples of 10. In multiples of 5 also I have multiples of 10. It means that I have taken the 10 multiples here and also here. I have taken it 2 times. So which means I am supposed to remove it 1 time. That means minus sum of the multiples divisible by 2 and 5. 2 and 5 means numbers divisible by 10. Okay. So sum of the numbers divisible by 2 plus sum of the numbers divisible by 5 minus sum of the numbers divisible by 10. Let me find out the sum of the numbers divisible by 2. S of 2 is equal to what? The sum of the numbers divisible by 2 from 1 to 5, 1 to 100. What are they? 2 plus 4 plus 6 and so on up to 100. Right? This is the sum of the numbers divisible by 2. So if I take 2 common, I will get 1 plus 2 plus 3 and so on up to 50. The sum of the first 50 natural numbers. We have a formula already. So what is that formula if you remember? Sigma n is equal to n into n plus 1 by 2. Correct? So here n value is 50. So therefore 2 as it is. Now the sum of these numbers is 50 into 50 plus 1 by 2. So cancel and cancel this. Here you will get 0, 5, 2, 5. The sum of the numbers divisible by 2 is 2550. So here you can write 2550 plus. Similarly, now let us find the sum of the numbers divisible by 5. The sum of the numbers divisible by 5. Sum of the numbers divisible by 5 means, let me add all the 5 multiples from 1 to 100. 5 plus 10 plus 15 and so on up to 100. These are the 5 multiples. If I take 5 common, 5 1s are, 5 2s are, 5 3s are and so on, 5 20s are. Now once again 1 plus 2 plus 3 up to 20. So I can use this formula. The sum of the first 20 natural numbers. What is it? 20 into 20 plus 1 by 2. So 5 times 20 into 20 plus 1 by 2. N into n plus 1 by 2. Where n value is 20. So if you cancel out 2 1s are, 2 10s are, we get 1050. So the sum of the 5 multiples is 1050 minus. Now similarly we can find the sum of 10 multiples. The sum of the 10 multiples, what are they? Sum of the 10 multiples is equal to 10 1s are, 10 2s are, 10 3s are and so on up to 100. So if I take 10 common, you will get 1 plus 2 plus 3 and so on up to 10. Use this formula again, 10 as it is. Use this formula again, 10 into 10 plus 1 by 2. 10 into 10 plus 1 by 2. So 2 1s are, 2 5s are, you will get 550. So minus 550. So what is our answer now? 2550 plus 1050 minus 550 is going to be, it's going to be 3050. So where is our option? First option. Okay. We'll go for the next question. Second question. Here is our second question. If mth term of an AP is 1 by n and the nth term of an AP is 1 by m, then what is sum of mn terms? Okay, so let us see the solution. It is given that mth term is 1 by n, correct? So mth term means am, it is equal to 1 by n. So am means what? A plus m minus 1 into d equal to 1 by n. Similarly, the nth term is 1 by m. Nth term is 1 by m, which means what? Nth term means a plus n minus 1 into d equal to 1 by m. So it is equation 1 and equation 2. It is a pair of linear equations. I hope you remember this concept from 10th standard chapter of pair of linear equations. The two variables are first term and common difference. Pair of linear equations. To simplify it, see, to find the sum of mn terms, I should find the first term and I should also find the common difference. Okay. So in this case, what I'll do, first of all, to find the common difference, I will try to eliminate a. In order to eliminate a, I am supposed to subtract, right? Elimination method. So plus a becomes minus a and plus becomes minus and plus becomes minus. So plus a and minus a will get cancelled. Here and here if I take d common, here and here if I take d common, I will get m minus 1 minus of n minus 1. Please observe, minus of n minus 1 means minus n minus into minus plus 1 equal to 1 by n as it is and minus 1 by m. So minus 1 and plus 1 will get cancelled. I will get m minus n into d is equal to, if I take common denominator, into m into m into n into n. I got a common denominator mn and the numerator is m minus n. So again m minus n and m minus n ones are. So therefore what is the common difference? The common difference is equal to 1 by mn. Common difference is equal to 1 by mn. Okay, next. So I got common difference. I can substitute in any one equation, either in first one or second one. Let me substitute common difference in first equation. What I'll get in first equation? A plus m minus 1 into the common difference is 1 by mn equal to 1 by n. Let me transpose to find a value. So a is equal to, if plus of this term goes to the right side, it becomes minus of. So 1 by n as it is minus m minus 1 by mn. I'll multiply the denominator and numerator now with m. So therefore a is equal to, with common denominator mn, the numerator is m and minus is for both the terms. Please observe. Minus into m, minus into minus, plus 1. Children, the most common mistake that I have observed is, whenever minus is for two terms, they will give minus for only m and they will forget it here. So don't do that kind of mistake. Minus is for both the terms, so minus m plus 1. Okay, again plus m minus m gets cancelled. Therefore the first term a is also 1 by mn. Observe one thing, the common difference is 1 by mn and the first term is also 1 by mn. Okay, now we are supposed to find sum of mn terms. So let us work out on that. Sum of mn terms. We know that Sn is equal to n by 2 into 2a plus n minus 1 into d, right? But they are asking sum of mn terms. So sum of mn terms is equal to, the number of terms is mn. So n becomes mn by 2 into 2a plus mn minus 1 into d. Let me substitute a and d as 1 by mn. Mn by 2 into 2 times a is 1 by mn plus mn minus 1 into, the common difference is also 1 by mn. I can take 1 by mn common, right? In these two terms, take it outside. Mn by 2 as it is. This 1 by mn, if it comes outside, 1 by mn, we get 2 plus mn minus 1. So mn and mn gets cancelled. Therefore the final answer is what? Mn, and 2 minus 1 is plus 1 divided by 2. So therefore the sum of mn terms is equal to mn plus 1 by 2. Mn plus 1 by 2. That is the answer. Mn plus 1 by 2. So you can check which option is correct and you can mark it. Okay. Sometimes in the same question, instead of asking sum of mn terms, they will ask you what is the value of a minus d. So what is the value of a minus d? A minus d is 1 by mn minus 1 by mn, it is 0. Correct? Sometimes they can ask this also. A minus d value is 0. We'll go for the next question. Here is our third question. So I would like to ask you to note down the question, because to explain the solution I will erase the question. Okay. So if S1, S2, S3 and so on Sq, what are this? They are the sum of n terms of q different arithmetic progressions. Please understand the question. What does it means? What does the statement means? For the first arithmetic progression, S1 is the sum of n terms. For the second arithmetic progression, S2 is the sum of n terms. For the third arithmetic progression, S3 is the sum of n terms. And for the last arithmetic progression, the qth arithmetic progression, SQ is the sum of n terms. So all these are sum of n terms only, but for different arithmetic progressions. Okay, do not misunderstand here that S1 means sum of one term. No, it's not that. According to the definition of the question, you have to understand the meaning. Okay, so these are the sum of n terms of q different APs whose first terms are given by 1, 2, 3 and so on q. What does it mean? For the first AP, the first term is 1. For the second AP, the first term is 2. For the third AP, the first term is 3. And for the last AP, the first term is q. Similarly, their common differences are what? 1, 3, 5 and so on, 2q minus 1. So which means for the first AP, the common difference is 1. For the second AP, the common difference is 3. For the third AP, the common difference is 5 and so on. For the last AP, the common difference is 2q minus 1. In that case, what is S1 plus S2 plus S3 and so on SQ? So which means what they have done here? They have added sum of n terms of the first AP, sum of n terms of the second AP, sum of n terms of the third AP and so on, sum of n terms of the last AP. They have taken the sum of the sum of n terms. And which option is correct, they are asking. Okay, now let us see the solution. To write the solution, I will erase the question. I hope you have noted it down. Okay, now to make the solution look easier, I'll do it in the form of a table. I'll take the first AP, AP1. Okay, then AP2, the second AP, AP3, the third AP, and so on, APQ, the qth arithmetic progression. Okay, now next. For all of these APs, what are the first terms according to the question? 1, 2, 3 and so on q. These are the first terms. Okay, and what are the common differences according to the question? 1 is the common difference of first AP, 3 is the common difference of second AP, 5 is the common difference of third AP and so on. 2q minus 1 is the common difference of the qth AP. And let me find the sum of n terms of each AP. Sum of n terms of each AP. For the first AP, sum of n terms is S1. What is the formula says? Here n is not 1. Please understand, n is number of terms. Here n means n only. N by 2 into 2a plus n minus 1 into d. Because sum of n terms formula is n by 2 into 2a plus n minus 1 into d. Okay, the sum of n terms, n by 2 into 2a plus n minus 1 into d. So a is 1, d is 1 for the first AP. Don't simplify it. Let us go for the next one. S2 is what? Sum of n terms of second AP. What is it? N by 2 into 2a, because a is 2 here, plus n minus 1 into the common difference here is 3. Next, S3 is equal to n by 2 into 2a, a is 3 here, plus n minus 1 into the common difference is 5. And so on. What is SQ? Again n by 2 into 2a, 2a means 2q plus n minus 1 into the common difference is 2q minus 1. Now we are going to add all this. Please see, because they are asking S1 plus S2 plus S3 and so on SQ. S1 plus S2 plus S3 and so on SQ is equal to. See what happens? See, in overall terms we have n by 2 everywhere. I'll take n by 2 common. N by 2 common. Next. Again inside if you see, in the first term everywhere we have 2. I'll take 2 common. When I take 2 common, what happens? 1 plus 2 plus 3 and so on up to q. 1 plus 2 plus 3 and so on up to q. Similarly, in the second term everywhere we have n minus 1 common, plus n minus 1 into 1 plus 3 plus 5 and so on to q minus 1, right? 1 plus 3 plus 5 and so on to q minus 1. Close the brackets. If you simplify the final answer, you will get the answer. So what is it? I'll erase it. So therefore, the question S1 plus S2 plus S3 and so on up to SQ is equal to n by 2 as it is into 2 as it is into the sum of first q natural numbers. 1 plus 2 plus 3 and so on up to q is q into q plus 1 by 2. Next plus n minus 1 into, and this is the sum of first how many odd natural numbers, because the last term is 2q minus 1. If last term is 2q minus 1, then the number of odd natural numbers is q, correct? So, and we have already discussed this formula in the previous videos, that the sum of the first q odd natural numbers is q square. In case if you don't know this, see the last before video. Okay, na? So in that I have explained clearly. Fine. Now what we can do is, let us cancel 2 and 2, and we will expand the thing inside. N by 2 into q is q square, plus q into 1 is q, plus q square into n is nq square, minus q square 1s are q square. What gets cancelled? Of course, minus q square and plus q square will get cancelled. In the remaining two terms, I can take q common. So n by 2 as it is, and I took q common. Here 1 plus nq. So where is this option? This is option A, right? So practice these kind of questions so that it becomes easier for you. We'll go for the next question. Here is our next question, fourth question. If a1, a2, a3 and so on an are in AP of not zero terms, the terms cannot be zero, keep this in mind. In that case, what is 1 by a1 into a2 plus 1 by a2 into a3 and so on, 1 by an minus 1 into an. So those are the four options. Let us solve it and let us check it. First of all, these kind of questions are very important. Directly they are not sum of terms in AP, but if you simplify it, I can convert it into the terms in AP. Okay na? So what to do? Please understand one thing. Particularly when the question contains a1, a2, a2, a3, a3, a4 and so on. Particularly when the question contains terms like this. We know that a2 minus a1 is common difference D. a3 minus a2 is also D. Next one, a4 minus a3 is also D, and so on. an minus 1 is also D. Since all are equal to common difference, I'll do one thing. I'll multiply the entire numerator with common difference D and the denominator with D. So what happens? In our first step, the entire numerator, here numerator is multiplied with D, here also with D. And if you know what is the third term, D by a3, a4, okay, and so on. Here also I have multiplied with D. So the entire numerator is multiplied with D. Then the denominator also must be, right? So the denominator D, I'll write it outside the bracket. Okay, outside the bracket. Now, fine. The numerator and denominator are multiplied with D. Next, 1 by D as it is. Here, instead of the common difference D, I'll write a2 minus a1. Okay, the denominator as it is. Or let us do one thing directly. And the denominator is a common denominator, right? a1, a2, I'll separate it. a1, a2, a1, a2. Next. Here the common difference D can be written as what? a3 minus a2 in terms of the denominator. Okay. Next. And the common denominator a2, a3, a2, a3. Here the denominator will be written in term, what is it? The common difference can be written as what? a4 minus a3 in terms of the denominator. Okay. And the common denominator a3, a4. Here also a3, a4. And so on. Here the common difference can be written as an minus an minus 1, and let us separate the common denominator. An minus 1 into an minus 1 into an. Close the bracket. Now see what terms get cancelled. A2 ones are and A2. A1 ones are and A1. A3 A3. A2 A2. A4 A4. A3 A3. And here an and then an minus 1 an minus 1. Okay. So next, if I write what I got here, 1 by a1 minus 1 by a2 plus 1 by a2 minus 1 by a3 plus 1 by a3 minus 1 by a4 and so on, 1 by an minus 1 minus 1 by an. Now the most important and decisive step, what is it? See, it is easy to say who gets cancelled in the first pair, second pair, third pair and so on. Who gets cancelled? It is easy to decide. So minus 1 by a2 plus 1 by a2 minus 1 by a3 plus 1 by a3, then automatically minus 1 by a4 plus 1 by a4 and so on will get cancelled. But in the last pair, who will get cancelled and who will be there in the solution? To know that, please observe this logic. In the first pair, the second one got cancelled. Therefore, in the last pair, the first one will get cancelled. So keep this in mind. For example, if in the first pair, the first one got cancelled means in the last pair, the last one will get cancelled. Just keep this in mind, okay na? Here in this particular problem, in the first pair, the second one got cancelled. So in the last pair, the first one will get cancelled, okay na? So this particular thing is very, very important. Keep this in mind. Now I'll erase these steps to continue. Yes, so it is equal to 1 by d into, I got 1 by a1 minus 1 by an. Okay, again I will take common denominator, an minus a1 by a1 an. Just two more steps, we will get our answer. What is it? 1 by d as it is. The nth term is a plus n minus 1 into d minus the first term is a. With common denominator a1 an. So plus a minus a gets cancelled, and after that the numerator contains only n minus 1 into d. So into d and by d gets cancelled. The final answer is n minus 1 by a1 into an. That is our final answer. N minus 1 into a1 into an. Please observe, it is option C. N minus 1 into a1 into an. Okay na? So I hope you understood this. We'll go for the next question. Next question is similar to this model, but observe carefully. Yes, fifth question. If a1, a2, a3 and so on, an are in AP, then what is secant of a1 into secant of a2 plus secant of a2 into secant of a3 and so on, secant of an minus 1 into secant of an. Of course, a question that comes under progressions and also trigonometry, correct? So kind of advanced level model, but solution is very easy. Just observe carefully. So which option is correct, they are asking. Okay, if you have noted the question, I will erase it. I'll erase it and I will solve it. Okay, fine. What is it? The question is equal to secant a1 is 1 by cos a1 into secant a2 1 by cos a2. So 1 by cos a1 cos a2 plus 1 by cos a2 into cos a3 plus and so on plus 1 by cos an minus 1 into cos an. Okay, now the decision making step. By practice you'll get these kind of ideas, but if it is first time, just think why we are doing this. What I'm going to do is, in the previous question I multiply with common difference in the numerator and denominator, and in this question I'll multiply with the sign of common difference in numerator and denominator. Okay na? So sign of common difference. So sin d by cos a1 cos a2 plus sin d by cos a2 cos a3 plus and so on plus sin d by cos an minus 1 into cos an. If I multiply with sin d in numerator, I am also supposed to multiply the denominator. Do not forget this. So 1 by sin d, that will be taken outside. Okay now, next step is common difference can be written as this common difference in terms of a2 and a1. What is it? I am doing it here itself. This common difference is a2 minus a1, and this common difference is a3 minus a2. If you write the next term, there the common difference will be a4 minus a3, and so on. The last common difference, what is it? an minus 1. Okay. Now let us use sin of a minus b formula. Got it? So sin of a minus b formula, sin of a minus b is sin a cos b minus cos a sin b. And this is the common denominator, so I will write it for both the terms. What is it? Cos a1 into cos a2, and here also cos a1 into cos a2. Similarly, here what I will write, sin of a minus b again, sin of a minus b, sin a cos b minus cos a sin b, and the common denominator cos a2 into cos a3, I will write here cos a2 into cos a3, and here also cos a2 into cos a3. Okay na? And so on. If possible, you write the next term also. This is the first term, this is the second term. You try to include third term to have more clarity in the solution. I am not writing the third term because the space is not enough on the board. Okay, but you try to write it. The first term, the second term. Try to include third term. What is third term here? Sin of a4 minus a3 divided by cos a3 into cos a4. You please mention that also in the solution. Okay, and so on. The last one. What is it? Sin of a minus b, sin a cos b minus cos a sin b, and the common denominator can be separated for this term and also this term. It is cos an minus 1 into cos an. Here also cos an minus 1 into cos an. Now see what gets cancelled. Cos a1 and then cos a2, cos a2 and then cos a3, and next cos an minus 1 and here cos an. Sometimes children will ask, sir, you multiplied numerator denominator with sin d. Why sin d? Why not cos d? They have asked it. If you want to know the answer, you do it. You multiply numerator and denominator with cos d and follow the process. Check whether you will get the answer or not. Then you will get a clarity. Why we have chosen sin d instead of cos d. Why I multiplied the numerator and denominator with sin d instead of cos d. There you will get clarity. Okay na? Now let us continue. So 1 by sin d as it is. Sin a by 2 by cos a by 2 is tan a by 2 minus sin a1 by cos a1 is tan a1 plus sin a3 by cos a3 is tan a3 minus sin a2 by cos a2 is tan a2, and you can easily imagine what is the next term in this series. a2 minus a1, a3 minus a2, and then I am writing the next term actually. What is it? Tan a4 minus tan a3, so that you will have a clarity. That's it. Plus and so on. Finally, what is the last term? Tan an minus tan an minus 1. Again, another decision making step in the solution. This is the first pair, second pair, third pair, and so on, last pair. Another decision making step. Very important step. Okay now, that is star symbol. Please don't misunderstand it. It doesn't look like it's okay. Now plus tan a2 and minus tan a2 will get cancelled, and then plus tan a3 and minus tan a3 gets cancelled, and so on. If you observe the first pair, the second term is remaining. That means in the first pair, the first term got cancelled. Then in the last pair, the last one will get cancelled. In the first pair, the first one get cancelled. So in the last pair, the last one gets cancelled. Okay na? This is very important. In the first pair, if second one gets cancelled, then in the last pair, the first one will get cancelled. Okay na? Opposites. In the first pair, the first one got cancelled. So in the last pair, the last one will get cancelled. Logical, remember this. So equal to 1 by sin d into plus tan an minus tan a1 are remaining. So this is there in the second option, option B. Okay, so fourth question and fifth question are of same models. They need repeated practice to remember. If you are solving these questions for the first time, repeated practice is important to remember them for longer time. So keep this in mind. So we'll go for the next question. Here is our sixth question. If the sides of a right angle triangle are in arithmetic progression, then the sines of acute angles are. What does it mean? The sines of acute angles. What are they trying to ask? Let me consider a right angle triangle. They told that the three sides of this right angle triangle are in AP. Okay, now. So let the three sides of right angle triangle are A minus D, A and A plus D. So generally, if three sides are in AP or if three terms are in AP, we will consider them as A minus D, A and A plus D. Okay, now. Where the first term in this case is A minus D and the common difference is D. We will discuss more about this in properties of arithmetic progressions in the next video. For now, the three sides of right angle triangle is what? A minus D, A plus D. You can also take it as A plus D, A plus 2D. And please observe, A plus D is hypotenuse. It is the longest side. A plus D is the largest value in this three. Because A plus D is the hypotenuse of these three numbers, who is the largest? A plus D. So which means that I have taken common difference as positive common difference. Okay, keep this in mind. Increasing order, they are in increasing order. The common difference is positive. Now, what they are asking, if the name of the triangle is triangle ABC, where angle B is right angled, they are asking sine of acute angles. The two acute angles in right angle triangle are angle A and angle C. So therefore, they are asking the sine of the acute angle A, sine A, and sine of the acute angle C, sine C. They are asking us to find sine A and sine C. Very simple. Use Pythagoras theorem. Find the value of A in terms of D. Get your answer. That's it. Very simple. So before I complete the solution, if you can, you complete it using Pythagoras. Okay. Now let us use Pythagoras theorem in the triangle ABC. So which means that A minus D whole square plus A square is equal to A plus D whole square. So what does Pythagoras theorem says? The square of the hypotenuse is equal to sum of the squares of the other two sides. Now let us expand it and simplify it. A minus B whole square. A square minus 2AD plus D square. And here plus A square equal to A plus D whole square is A square plus 2AD plus D square. Now you can transpose A square to the right side and cancel it. And transpose plus D square to the right side and cancel it. Finally, A square is equal to, if minus 2AD goes that side, plus 2AD, we will get 4AD. And remember one thing in this, here A is there, here also A is there, right? I can cancel it because A is not equal to 0. Because it is a side of the triangle. A cannot be 0. There is no such triangle in which the side is equal to 0. Since A is not equal to 0, I can happily cancel it. Therefore, what I got here? I got A is equal to 4D. So, therefore, dear students, what is the first side? A minus D. A minus D means what? 4D minus D. 4D minus D is 3D, correct? 4D minus 3D, 4D minus D is 3D. Next, A means what? 4D. Next, this is A plus D. That means 4D plus D, it is equal to 5D. Therefore, what are the three sides? 3D, 4D, 5D. The sides are 3D, 4D and 5D. And they are asking sin A. Sin A means what? For angle A, sin A means opposite BC by hypotenuse AC. So, opposite by hypotenuse BC by AC. BC by AC. BC 4D by AC 5D. DD cancels. Therefore, what is sin A value? 4 by 5. Next, sin C. Sin C means for angle C, opposite by hypotenuse. Opposite is 3D by hypotenuse 5D. So, 3D by 5D and D gets cancelled, I'll get 3 by 5. Therefore, the sine of the acute angles is 4 by 5 and 3 by 5. Where do we have this? In the first option, 3 by 5 and 4 by 5. And we'll look at the last question in this series and then we'll conclude the topic. Our seventh question, if 1 plus 3 plus 5 up to p, I'm not saying p number of terms, p is the last term, please understand this, plus 1 plus 3 plus 5 up to q is equal to 1 plus 3 plus 5 up to r. Okay, now then the sum of the smallest possible value of p plus q plus r, sum of the smallest possible value of p plus q plus r where p is greater than 6. Okay, now it's time to decide the number of terms in this particular AP if last term is p. Okay, let me take the AP 1, 3, 5 and so on. The last term is p. I'm not saying p number of terms. Don't misunderstand and don't write p square here. No, it is not p square. So the last term is p. Okay, now the nth term, that means a plus n minus 1 into d. The nth term is equal to p, where a is 1 plus n minus 1 into common difference is 2 equal to p. So what do you get? 2n minus 2 plus 1, that means minus 1 equal to p. So 2n is equal to p plus 1 and n is equal to p plus 1 by 2. Therefore, the number of terms is equal to p plus 1 by 2. And we know that the formula to find the sum of first n, not first n, we know that 1 plus 3 plus 5 and so on, n number of terms is equal to n square. Correct or not? We know this already. Now, therefore, what is the first one? I'm coming to the question. Here the number of terms is p plus 1 by 2. You got it? Therefore, the sum is p plus 1 by 2 whole square. If the number of terms is n, the sum is n square. If the number of terms is p plus 1 by 2, then the sum is p plus 1 by 2 whole square. And what about this? Q plus 1 by 2 whole square, because the number of terms will be q plus 1 by 2, just like this, is equal to, what about this? The number of terms will be r plus 1 by 2, therefore it is equal to r plus 1 by 2 whole square. Next, dear students, in the question they told that p is greater than 6, correct or not? Let us come back to this. P is greater than 6. Add p on add 1 on both sides to get p plus 1. So p plus 1 is greater than 7. Next, divide with 2 on both sides. P plus 1 by 2 is greater than 7 by 2, which means 3 by 5, 3.5. Now, do you remember the Pythagorean triplet? Pythagorean triplet, where this number is just more than 3.5. Just more than 3.5. This number is just more than 3.5. Yes, if you know it, what is it? 4 square plus 3 square is equal to 5 square. The Pythagorean triplet, where this number is just more than 3.5 is 4. Correct or not? 4 square plus 3 square is equal to 5 square. So where p is equal to 4, q is equal to 3 and r is equal to 5. A small correction, p is not 4. What is it? Where p plus 1 by 2 is 4. P plus 1 by 2 is 4. Cross multiply and we get p is equal to 7. Okay, now next, q plus 1 by 2 is equal to 3. Q plus 1 by 2 equal to 3. Cross multiply, q is equal to 5. And next, r plus 1 by 2 is equal to 5. R plus 1 by 2 is equal to 5. Cross multiply and then r is equal to 9. Therefore, p plus q plus r. What is p plus q plus r? 7 plus 5 plus 9. It will be equal to 21. 7 plus 5 plus 9 is 21. This is the smallest possible value of p plus q plus r. Got it? We have so many other Pythagorean triplets. For example, if you take 6 square plus 8 square is equal to 10 square, then we will get different value of p plus q plus r. Okay, na? So for different Pythagorean triplets, we will get different p plus q plus r values. Out of that, the smallest is 21. Okay, so it is option B. So dear students, at the end of this chapter, okay, na, sequence and series, around maybe some 25 to 30 videos are possible. In that, at the end of these videos of sequence and series, I will also upload last year questions. mains model questions and advanced model questions from this particular chapter. Okay, there we will discuss even more model questions. So for now, these are the questions. I have discussed many models, frankly to say, and all the other models will be covered when I discuss the previous year questions, okay, now which are given in mains and also advanced. So in that particular video, we will discuss even more questions. So meanwhile, I hope you understood this particular problems. So and if you have understood it, just like the video and comment if there is something that you want to share with me. And your feedback is always important. That helps me to improve the ways of explaining a particular concept to the students, and it brings closer to you all. Okay, thank you. So thank you. We'll see you in the next video.